The molecule IBr has a bond length of 2.49 angstroms and a dipole moment of 1.21 dBi. Which atom is expected to have the negative charge? And we want to calculate the effective charges on each molecule or each atom in terms of E, which is the charge on an electron. So in this case, the equation we want to use is that mu equals QR, where this is the charge, we have the bond length, and this is the dipole. And so we can also determine which atom is expected to have the negative charge first. So we have the I-Br bond, and Br has a higher electronegativity, so we know that the dipole moment will go in this direction. And so now we want to calculate what the partial charges are on each atom. So in this case, if we know that the dipole moment is 1.21 dBi, and that's equal to Q times 2.49 angstroms. Okay, and so we know that both of these units are not going to cancel, and so we need to convert them. And so 1.21 dBi, 1 dBi is 3.34 times 10 to the negative 30 coulometers. Okay, so this will get us into one set of units, times Q, 2.49 angstroms converted to meters, where 1 angstrom is equal to 1 times 10 to the negative 10 meters. From here, we can actually solve for Q, and that is 1.62 times 10 to the negative 20 coulombs. So now we know the charge on each atom in terms of coulombs. While coulombs is effective, the problem is asking for the charge of an electron, and so we need to convert this value to the charge on an electron. So 1.62 times 10 to the negative 20th coulombs times, if we want this to be in terms of one electron, the charge on one electron, the charge on an electron is 1.60 times 10 to the negative 19. When you plug that in, you get 0.101 electron. And so now we know that the charge on the bromine is going to be negative 0.101 E. And so we know that in terms of an electron, roughly 10% of the charge is on the bromine. So what we did is we converted dBi into coulometers, angstroms into meters, divided the dipole moment by the radius, solved for Q, converted Q into terms of an electron in order to determine the charge on the bromine.